Hello everyone, welcome to the lecture on Unit 1 of Mechanics of Solids, that is simple stresses and strains. In the previous classes, we had already looked at some concepts up to this lateral strain and Poisson's ratio. So let us continue the class. Let us move forward. So in the previous class, we had discussed until lateral strain and the Poisson's ratio. So the strain which is at right angles to the direction of the applied load is known as lateral strain, and the strain in the direction of the applied load is known as longitudinal strain, and the ratio of lateral strain to the longitudinal strain or the linear strain is known as Poisson's ratio. So this Poisson's ratio is denoted by this letter mu. So therefore mu is equal to lateral strain divided by linear strain. And Poisson's ratio is generally constant for a given material, and its value is 0.3 for a mild steel. So let us move forward. Next concept is elastic moduli. So there are three elastic moduli. The first one is Young's modulus, second one is shear modulus, and the third one is bulk modulus. So let us understand them one by one. So what is Young's modulus? So Young's modulus is the ratio of stress to the strain within elastic limit. Okay, so this Young's modulus is calculated within the elastic limit, and it is the ratio of stress to the strain within that elastic limit. And Young's modulus is generally denoted by the letter E. So therefore, E is equal to sigma divided by epsilon within the elastic limit. Okay, where this E is Young's modulus, sigma is the stress, and epsilon is the strain. So it is also known as the modulus of elasticity, and this Young's modulus is a constant for a given material. Okay, and the unit of this Young's modulus is same as that of stress, that is Newton per mm square. If you see here, if you look at the formula, it is stress divided by strain. The unit of stress is Newton per mm square, and the strain is unitless. So therefore, Young's modulus is also having the same units as that of stress, that is Newton per mm square. So next elastic modulus is the shear modulus. So this can also be called as modulus of rigidity. So both shear modulus and modulus of rigidity both are same. So it is the ratio of shear stress to the shear strain. Okay, so it is generally denoted by the letter G. So therefore, G is equal to tau divided by gamma. So here tau is the shear stress and gamma is the shear strain. So you can see here where G is equal to shear modulus or the modulus of rigidity, or you can say rigidity modulus. Tau is the shear stress and gamma is the shear strain. Okay, next coming to the third one is the bulk modulus. So it is the ratio of the direct stress to the volumetric strain. So and it is generally denoted by the letter K. So how we can understand this bulk modulus? Let us consider this cube here. So when this cube is subjected to compressive stress, then there will be a decrease in the value. So this compressive stress is the direct stress. So here, in this case, direct stress, it may be tensile stress or it may be compressive stress. Okay. So if the stress is tensile, then there will be increase in the volume. If the stress is compressive, then there will be decrease in the volume. So the correspondingly we will be having the change in volume, and also there will be volumetric strain set up in the body. So therefore bulk modulus is the ratio of direct stress to the volumetric strain, and it is denoted by the letter K or V. Therefore K is equal to sigma divided by epsilon V. So where this sigma denotes direct stress, either it may be tensile or it may be compressive, and epsilon V denotes volumetric strain. So these are the three elastic moduli we have in our syllabus. Next, moving on, we have the relationship between Young's modulus and the shear modulus, and also the relationship between Young's modulus and bulk modulus, and the relationship between all these three moduli. So let us study them one by one. First, let us understand the relationship between E and G, that is Young's modulus and shear modulus. So there is a derivation here. In this class, what we can do is let us briefly understand the relationship between all these moduli, and in the next class we will derive the relationship between these elastic moduli. So the relationship between elastic moduli, the Young's modulus and the bulk modulus is given by E is equal to 2g into 1 plus mu, or E is equal to 2g into 1 plus 1 by y, 1 by m, because this 1 by m you can call it as Poisson's ratio, or you can substitute this 1 by m by mu. So then this is the relationship between Young's modulus and the shear modulus. Next, moving on, the relationship between Young's modulus and the bulk modulus. So it is given by E is equal to 3k into 1 minus 2 mu, or you can say E is equal to 3k into 1 minus 2 by m. So here again 1 by m is Poisson's ratio, that you can write it as mu. Therefore E is equal to 3k into 1 minus 2 mu is the relationship between E and K, or you can say Young's modulus and bulk modulus. Now relationship between Young's modulus, shear modulus and bulk modulus. So what is that? E is equal to 9 kg divided by 3k plus g. So here in this relationship between, we have the relationship between all the three elastic moduli, that is E, G and K. So this is the relationship between E, G and K. So how to derive these things we will see in the next class. Okay, thank you.